Hello, my name is Richard Lanyon-Hogg. I'm a Professor of Computer Science at the University of Sheffield. I'm also a member of the British Computer Society Green IT Specialist Group, and I'm also a woodland owner. Over the next quarter of an hour, I intend to provide an overview of a project which affectionately became known as the Internet of Trees, and also to ponder the question which arose in my mind as to whether the Internet of Things is really sustainable. As a sustainability project, back in 2005, some 15 years ago, myself and my wife, we bought a 40-acre wood from the Forestry Commission. It had been a softwood woodland, and being recently felled, we had planted 22,600 deciduous saplings, mainly oak, ash, alder, downy birch and willow. And subsequently, we've had a further 3,000 saplings planted, which included tissue birch and some cobnut. To give you an idea of the terrain of the wood, it's fairly flat, does rise up a bit at the back, it's kite-shaped, has a large lakelet and distant views over Cardigan Bay. Given the weather of West Wales, which generally is horizontal rain and gusty winds, we approached the local council and secured approval to build an off-grid lodge. We captured the rainfall into a holding tank via a stainless steel filter and via a further paper filter and UV sterilisation unit, we have clean drinking water. Power is provided by a solar panel and Rutland Marine wind turbine. For heat, we have a wood burning stove, and for all our waste, we have a composting system. So now we're truly isolated and off-grid to tend to the wood. However, when we're not there, how do we know how the wood is? How does it feel? I realise that's a qualitative question, but with quantitative analysis, might it be possible to determine the health of a tree or a wood? So the idea was born, the Internet of Trees. Being a member of the Small Woods Association, I spoke to their team to test the appetite of what interest there might be in potentially using technology to monitor and report on the health of a tree, or even an entire woodland. Discussions quickly progressed with the Small Woods Association, which then included the Forestry Commission Research Council and the London Wildlife Trust. With mounting interest, a workshop was held with all the interested parties, including amateur and professional foresters. This was back in 2017. At the workshop, a whole gambit of IoT technology was demonstrated. It included Arduino boards, boards from Intel, as well as Raspberry Pis. These boards were attached to a series of sensors, and via a cloud system we had established, using simple analytics and a dashboard, we demonstrated how you could sense the environmentals of a tree and present the resulting data. We explored the many different sensing options, as you can see on the right-hand chart. So not only could we monitor temperature, humidity, moisture, illumination and electrical conductivity, but we could also sense such things as tree movement and airborne chemical attacks on the tree. Electrical conductivity was especially interesting as we later demonstrated how using conductive rubber we could detect the expansion and contraction of a tree trunk as the sap was rising and falling during the day. A little like monitoring human breathing. The workshop confirmed that there was an appetite to run a pilot, so we went ahead and designed a specific circuit board for the trial, and working with the Advanced Manufacturing Research Centre in Sheffield, we had designed and 3D printed a case to enclose the IoT circuitry. The 3D printed case was in the shape of a leaf, as you can see on the chart, and it was also found to be quite a tactile object. So During 2018 and 2019, we operated several live trials. We sensed up an oak tree, silver birch trees and some willows, both single trees and those in a woodland setting. Where online communication was possible, we streamed the live data into a cloud-hosted NoSQL database. The data was JSON structured for easy access by citizen scientists. And we also provided for foresters the data via the dashboard. Using a data logging application which we developed for a smartphone, offload data was also uploaded to the cloud to enable it to be merged with other synthetic data sets and public data sets such as weather data. As with the initial workshop, the pilot confirmed that using IoT technologies, it was possible to monitor the health of a tree, and using mathematically scaling models, we could offer an informed view as to the health of the whole wood. But what lessons did we learn from the pilots? From a technology perspective, and as we all know now, the IoT is an accessible and affordable platform. The boards are cheap and very capable. The skills required to manipulate the technology to meet your own needs are easily accessible and doable for most individuals. I also felt that there is a growing acceptance across many groups of people that technology is now a way of life. And for amateur woodland owners, such as myself, then why not use technology to monitor a tree or even a wood? From a field trial perspective, the lessons were quite different. Many woodland creatures took to the IoT packaging, the Internet of Trees packaging, as one of its 5-a-day meals. Quite often I'd find bits chewed off. Especially in a woodland setting, power was an issue. Yes, there has been tremendous strides made in battery technology, but if you're going to monitor a 40-acre woodland, we had calculated you need between 10 and possibly 20 IoT packages. So whoever was responsible for maintaining the package would need to know precisely where they were in the wood. And remember, woods are constantly growing and changing, and GPS signals are affected by wood and moisture. We did explore doing away with batteries altogether. Small solar panels were discarded though, as they quickly became covered in slime and lost their effectiveness. We also considered energy from motion, but in the middle of a wood, there's little motion, as at the edge of the wood, it acts as a baffle, and so the wind tumbles across the tops of the trees. So power was an issue, and communications was also an issue. Offline data capture was fine, so long as the micro SD card remained intact. We found moisture, damp, frost and heat a constant challenge, which required changes and modifications in the Internet of Trees packaging to avoid microclimates within the unit. Online live streaming of data was fine if we had access to a Wi-Fi bubble provided by an on-site woodland cafe or recreational centre. As recently as last winter, we'd started to investigate using a low orbital satellite service to upload small 256 byte packets of data every 24 hours. So I felt that providing we could get the maintenance of the IoTR package resolved, we could provide a viable service to woodland owners with open, trusted and reliable data being made available to citizen scientists and other interested parties. But, and there's always a but, I just felt this whole approach wasn't sustainable. We're all familiar with the periodic table of elements. This chart illustrates how over the last 30 years you can see the growth in the silicon technology industry's use of Mother Earth's resources. Before 1990, only 6 elements were employed. From 1990 to 2005, this grew to 14. Now, over half of all Earth's elements are used in materials innovation to satisfy our digital needs. Personally, I'm unable to justify using such an array of precious elements to simply monitor the health of a tree or a wood. The IT industry talks a great story about being sustainable. Really? The industry doesn't design for disassembly, whether that's hardware or software for that matter. Back in 2016, I spent 6 months volunteering at the National Museum of Computing, Bletchley Park. In one of their storage huts, which the public has no access to, is a history, a legacy of the IT industry, aisle upon aisle, row upon row of stuff which was never fully utilised, only for it to be superseded by the next big thing, the next big wave. The IoT is driving our planet, our only home, to be connected up with billions of devices. So to conclude, if we are to move to a more sustainable future, time is not our friend. We know what has been gained from technology, but what the Internet of Trees project has illuminated to me is that we're at a tipping point. The Internet of Things has the potential to be the next plastics disaster. Let us not lose what we and previous generations have enjoyed. More importantly, let us not forget what may be lost. Thank you.